Hello everyone, I'm Soumya Upadhyay from SRM Institute, and today I'll be explaining the Floyd-Warshall algorithm. The contents that we'll discuss in this video are the Floyd-Warshall algorithm, representation, we'll discuss a lead code problem, pseudocode and algorithm for the lead code problem. So what is Floyd-Warshall algorithm? The Floyd-Warshall algorithm is an all-pair shortest path algorithm. Unlike other algorithms like Bellman-Ford, which are single-source shortest path algorithms. This algorithm works for both the directed and undirected weighted graphs, but it does not work for the graphs with negative cycles. The graph with negative cycles means where the sum of the edges in a cycle is negative. It follows dynamic programming to check every possible path going via every possible node in order to calculate the shortest distance between every pair of the nodes. So you'll be wondering what is the difference between Dijkstra's, Bellman, and Floyd. So this one is the shortest path from one node to all the other nodes. Bellman-Ford is the shortest path from one node to all nodes. Negative edges are allowed. Floyd-Warshall, shortest path between all pairs of vertices where negative edges are allowed. So let this be an example. We have 5 nodes here, A, B, C, D, and E, with directed and weighted graph. So we have to arrange this in a matrix form where A to A, B to B, C to C, D to D, and E to E will be 0 because the node can't travel to itself. So all these values will be 0 and the other value we can take from this graph. So this will be the resultant matrix. We arrive at this result after treating all the nodes A, B, C, D, and E as intermediate nodes one by one. So this is the lead code problem, Floyd-Warshall 2. A negative cycle. The problem is a negative cycle is one where the overall sum of the edges that form a cycle in a graph becomes negative. Input format we need is number of vertices, edge weight between the vertices entered, 1 per line. Constraints here are use adjacency matrix to depict the edge connections. Output format, the graph contains a negative cycle. This is the sample input and output. The Floyd-Warshall algorithm. So the first step is initializing the solution matrix, same as the input graph matrix is a first step. Then update the solution matrix by considering all the vertices as an intermediate vertex one by one. The idea is to pick all vertices one by one and update all the shortest paths, which include the picked vertex as an intermediate vertex in the shortest path. When we pick vertex number k as an intermediate vertex, we already have considered vertices 0, 1, 2, 3 up to k minus 1 as an intermediate vertex. For every pair I and j of the source and destination vertices, respectively, there are 2 possible cases. The first case is k is not an intermediate vertex in shortest path from I to j. We keep the value of distance ij as it is. If k is the intermediate vertex in shortest path from I to j, we update the value of distance I to j as distance ik plus distance kj. If distance ij is greater than distance ik plus distance kj. So the pseudocode for solving Floyd-Warshall algorithm is for k is equals to 1 up to k is equals to n minus 1. For I is equals to 0 to I is equals to n minus 1. For j is equals to 0 to j is equals to n minus 1, distance ij will be equals to minimum of distance of ij, distance of ik plus distance of kj, where I is the source node, j is our destination node, and k is the intermediate node. Thank you.